All right. Hello, wonderful people. Let's get started. All right. So today you'll be able to use the discriminant to determine the number and types of solutions. Determine the best method for solving a given quadratic equation. All right. So we've covered many ways to solve quadratic equations. The first method we have is graphing. It's probably one of the ones that we spent quite a lot of time on. So negative b over 2a. So we need to get our axis of symmetry. And that means, remember, once it's in standard form, it goes in A, B, C order. So A, B, C. So negative b would be, well, negative 6, because that's my b value, over 2a, which if you don't have a number or in your coefficient in front of the variable, then it's just going to be 1. So here I have, well, 2 times 1 down here, so that'd be 2. So this is 6 divided by 2, which is 3. And that gives us our axis of symmetry at 3. All right. But we also need to know where the vertex is to graph a quadratic vertex. So what we have to do is plug this in for x. So it'd be like f of negative 3, and plug in negative 3 everywhere we have x. So negative 3 squared plus, in this case I just need 6 times negative 3 plus 5. And then we evaluate this, and this should be the y coordinate for our vertex. So negative 3 times negative 3, so that's the definition of negative 3 squared. That would be 9. Negative 3 times positive 6 would be negative 18. And we get a mixture of positive numbers and negative numbers. So I'm going to combine my negative numbers first, or actually, sorry, my positive numbers, because I have 2 of those. So it's going to be 9 plus 5, and that would be 14. And 14 minus 18, 14 minus 18 would be negative 4. And this gives me my coordinate for the vertex. So my vertex is going to be at negative 3, negative 4. So back 3, down 4. And from here, I would usually make a table with a few values going up. So negative 2, 1, 0, maybe 1. And then a few values going down. So negative 4, negative 5, negative 6, negative 7. And then evaluate each one of those there. But remember, if you have no coefficient in front of your x squared, or a coefficient of 1, I should be more specific, or negative 1, you can use the rule of odds. So that means from the middle, go over, up 1, then from there, up 3, then 5, and if you can, you could probably get to 7, but it doesn't look like we'll be able to get to 7 in this case. And then do the same thing in the opposite direction. So 1, 1, and then up from there, 3, and then from there, 5. And then we do our best to connect the lines, which because of this tool doesn't always work out very well. So sometimes I gotta go a little bit past it. There we go. So again, this should be a rounded edge down here. Should be a nice smooth edge. So just sort of ignore these little points at the end that go past the axis of symmetry. And from here, we can see the solutions. It follows our rule of odds and crosses the x-axis right where it should. So the solutions to this are going to be what look like negative 5 and negative 1. X equals negative 5 and negative 1. and that is solve by graphing. Not a very precise method. Okay, it was one of the first ones we learned, and every time I get a chance to tell you what a solution is, then I'll usually show you the graph on what it looks like. So there you go. That's the first one. The other one is factoring. So when factoring, well, let's see. How do we use factoring? Well, we got to be able to use the reverse FOIL method, and we make our double bubble, and let's just see if we can do this. So we need two numbers that will multiply to our last number. So I need two numbers that will multiply to 5, which 5 does not have a lot of factors, so that makes it kind of an easy pick because 1 and 5 are the only numbers I can multiply to get 5. And then for the middle, I need two numbers, these same two numbers here, that will add to 6. And since it's a positive 6, that means this will be positive and this will be positive. So remember, this means they will be the same. If it is positive, that means they will be the same. And if they are the same, they will be the same as whatever the first one is. If it's negative, then that means they will be opposite signs in here. And then the first number, the last step is the first number. What two numbers can I multiply to get x squared? And in this case, we have a very small choice of factors, so we don't really have to check it, but let's just check it really quick. So let's use FOIL. X times x is x squared. Okay. Outside number is 5 times x, which is 5x. Inside is 1x, so 5x plus 1x is 6x. So working so far. Last number is 1 times 5, which is 5. And that's true. 1 times 5 is 5. All right, so there you go. This is factored in the correct way, but we have to use our zero product property. Zero product property says that one of these bubbles must end up being 0, or even both of them must end up being 0. So what can I plug in for x so that when we multiply it, we get 0? Okay, well, let's make this bubble into 0. X plus 1 equals 0. So if I were to minus 1 from both sides, x equals, I get my first solution, which is -1. All right, well, what can I plug into this bubble so that when I multiply it to this bubble, I will get 0? X plus 5 equals 0. So I'm going to set it equal to 0, just this factor. And I'm going to solve it so that I get x by itself. So by minusing 5, we cancel it on this side, and I get -5. And those are my two solutions, -1 and -5. And this is the same problem, same quadratic from the first example. In fact, we're going to be using this exact same one to cover all of the different methods that we have covered so far. All right, let's go on to the next one. And this will be the square root. Now in this case here, the square root, that is the one where if you only have two terms, so in this case, oopsie, we cannot use it since we have a b value or an x term, which means this number here. So with square roots, now that would be more of something like x squared minus 64 equals 0. This is just a really quick example. I would add 64 to both sides, x squared equals 64. And then take the root of both sides. And then we would get an answer such as x equaling positive and negative 8. So that's the square root method. I'm just going to show you a really easy example. Okay, just to show you a really easy example, because in this case we cannot use it for the quadratic that we were given, so just might as well cover it. Okay, let's go ahead and move on to the next method. So that was the square roots. And this one is completing the square. So with completing the square, this is the one where we have to move this number over to this side and have only the x numbers on one side. So this one does take a little bit of space. So I'm going to go ahead and move it over here. And I'm going to leave another space right here. So I'm going to minus 5 from both sides, and that's going to move it over to the other side as negative 5. And remember, this is the one where you take it, half it, square it. So your b value, so let's see, where can I put this at? Let's go here. So take it, half it, square it. I'd like to write this out, but you know, I can't write too many things at once. So this means that I need to add 9. And it also means that I would have to add 9 to this side as well to keep it balanced, so that both sides have the same thing going on both sides. So again, stays balanced. And the reason we do that is so we can make a perfect square trinomial. So when we factor it out, we should get a pair of double bubbles that have the same thing. So using the factoring, I need two numbers that can multiply to 9, but will add to 6. And again, sign is, this sign here, the second one, is going to tell us that they are the same. And they will both be the same as whatever the first one is. So in this case, they will both be a positive 3. 9 minus 5 is going to be 4. All right. Now, just to save some space when writing, I'm going to go ahead and put the square here while I erase one side of the parenthesis here. Because again, it means the same thing. But it also helps when I take the square root of both sides, right? Because in this case, I will need to take the square root of both sides because the square and the square root are inverse operations. So they are opposites. They will cancel each other out. X plus 3 equals, and we can take the square root of 4, which in this case is 2. But anytime we take the square root, we must consider the positive and the negative root. And then from here, we're going to break it into two equations. So x plus 3 equals 2, and x plus, or actually minus, that would be x minus 3. Oh wait, no. Sorry. Minus 2 goes over here. Okay, I was trying to kind of skip ahead here. But again, we got to consider both possibilities of this 2 being positive and negative. And again, don't switch anything else. All right, I got kind of carried away. I kind of thought we were, normally I would skip a step here, but I'm trying not to do it today. All right, so continue solving. So I'm going to minus 3. And since it's the same thing all the way around, I'm going to go ahead and just do this all at once. So our solution for this one, all right, so 2 minus 3 is negative 1. And negative 2 and negative 3, combine those together, and we will get negative 5. And again, it's the same problem, so it would make sense that we would keep getting the same solution. And that's how you complete the square. And we get to our method that we covered most recently, and that is the quadratic formula. Now, the quadratic formula does have one disadvantage, and that is you have to memorize how it goes. So it's negative b plus and minus the square root of b squared minus 4ac all over 2a. And again, it has to be like this, okay? If you're taking a test, it's going to be kind of hard to memorize because you'd have to remember all of these things and where each one goes and all that stuff, which is kind of hard to do. All right, so we have our A, and we can identify each of them. So A is 1, B is 6, and C is 5. So just identifying each one of them, we're going to plug these A, B's, and C's into our quadratic formula. So let's see, we got B, which is 6, so negative 6, because again, it's going to be the opposite, plus and minus square root of B squared, so that's 6 square minus, and this number is always 4. Take our A value, which is 1, and our C value, which is 5. All over 2A, which 2 times 1 is going to be 2A. There we go. All right, negative 6 plus and minus 36 minus 20, because 6 squared is 36, and 4 times 5, we can ignore the 1 because timesing anything by 1 is not going to make a difference. So 4 times 5 is 20, so we minus 20 all over 2. All right, and I'm just going to go ahead and combine the numbers underneath the radical here. So 36 minus 20 will be 16 over 2. From here, we're going to split it into 2 separate equations. So again, same thing, we got to consider the positive result. So the positive would be negative 6 plus, and I can take the square root of 16. Square root of 16 is 4 over 2. But we must also consider the negative possibility, and that is negative 6 minus 4. Again, square root of 16 is 4. So let's go ahead and see what our solutions will be this time. So negative 6 plus 4 is negative 2 over 2. Negative 2 over 2, which is negative 1. And negative 6 minus 4. Negative 6 minus 4 is negative 10 over 2, which if I were to divide negative 10 by 2, I get negative 5. And again, we get our solution of negative 1 and negative 5. So there you go. We covered the different ways that we could use each method to solve a quadratic equation. But how do you know which one is best? So factoring for this one seemed to work pretty good. I mean, with factoring, well, for me anyway, once it's factored, you just take the opposite here and you're pretty much done. So if you can factor it, that is, really good. It's fast, simple, but the problem is it doesn't work with all types of problems. So let's talk about how we can tell, right? How can you tell what's going to be the best way before you have to do a lot of work? Now, we call it the discriminant, and well, I think nowadays it sounds like a bad word, like discrimination. But to discriminate simply means, to put it somewhere. to basically make a group out of it. So by looking at this part, so if you remember the quadratic equation, there's this part right underneath the radical, the b squared minus 4ac. So when we were working with the quadratic formula, you may have noticed that sometimes you will get one root, imaginary roots, or you may get a radical expression root. Radical expression is something times the square root of something. Or you might get fractions, which would be rational, but that's okay. That's actually kind of easy to get. So all we do is we just look at that part. Just look at the part underneath the radical in the quadratic formula. And it's really only like 4 steps. We square it, times it, and subtract it. So if you look at the value of your discriminant, if your discriminant is greater than 0, which in this case means that it is a positive number, if your discriminant is positive, you will get 2 real and rational roots. So, okay, real number, we already covered that kind of, and rational means that it's not going to be a repeating decimal, or it's not going to be a square root of a number that will become a repeating decimal. But that's if it's a perfect square. If your discriminant is positive, but is not a perfect square, so if it's any number other than, say, 1, 4, 9, 16, 25, 36, okay, then it will be an irrational root, but there will still be 2 of them. If your discriminant is equal to 0, that means you will only have 1 root. And again, on a graph, that kind of looks like the graph that just touches slightly and then comes back up. And usually that's going to be a rational number. And if you get the discriminant less than 0, so remember the discriminant is a square root number. And if you have a square root number, that will cause it to be an imaginary number. Now, I know sometimes students may say no solution, and I would say that's kind of right. There is no solution, but it's also kind of not right because there is an imaginary solution. And again, that's a little bit of a difficult thing to explain, that it's not a real solution, it's an imaginary solution. But again, those are the kind of graphs that do not cross the x-axis. And since there is no crossing of the x-axis, there is no real root, no real 0 or solution. All right. So let's go ahead and practice these a little bit. All right, let's practice using the discriminant to find out what kind of roots and best method for solving an equation will be. All right, so it says only find the value of the discriminant. Determine the number and types of roots. All right, so let's go ahead and let's get that b squared minus 4ac. So let's see, this one looks like it's already in standard form. So let's go ahead and just put it together. So that's b squared minus 4 times a times c. Okay. Let's see, we got 144, and negative times negative is going to cause it to be a positive. So 4 times 2 is 8. 8 times 13, I don't know what that is. 26 times 4, okay. 26 times 4 is going to be a little bit easier because I know what 25 times 4 is. So that would just be 104. Add 104 to 144, and we get 248. Now, in this case here, we go back to our chart, and it's a positive number. So it means that it will have 2 roots. But the question is it a perfect square or is it not a perfect square? Okay, so to get a perfect square, I'm going to go ahead and go to my calculator. And 248 square root, which in this case, it is not a square number. Since it is not a square number, that means it is going to be, well, let's go ahead and put this down, 2 roots. But they are also going to be irrational. There we go. All right, so let's go ahead and plug this in and find out how many types of solutions, or how many solutions and what type they will be. All right, so b squared, so this is 16 squared minus 4 times a, which in this case a is a negative value, so -1 times -64. So 16 squared, I know what that is, 256. And we have 3 negatives. So 3 negatives is going to be, well, negative, because 2 of them will cancel each other out, but there will always be a third one left over. And 4 times 64 is going to be 256. So 256 minus 256 is going to be 0. And if we look at 0, so if the discriminant is equal to 0, that means we have 1 real and rational root. And while I'm at it, I'm also going to replace this one here. When typing, when having to write something, I really should type it out. All right, so there we go. We got the number of roots. So in this case here, we could probably, once we know what the discriminant is, we should know what method would be the best to solve that quadratic equation. All right, so with this one here, it looks like we're going to have to do a little bit of work to put it into standard form. So I'm going to minus 10x from both sides, and I don't have any like terms. So that's going to make it negative 4x squared minus 10x plus 84. And I got to set it to 0. And let's go ahead and put it together now. So we got negative 10 squared minus 4 times a, which in this case is negative 4, and c, which is 84. Now, if you have a calculator, this could go by a little bit faster. But let's see, 100. Well, we get 100 here because negative 10 times negative 10, and 2 negatives, so that must make it, that's going to make it positive. So this becomes 16 times 84. And that's going to be 1344, which when we put that together, it's going to be 1444. And that's a pretty big number. I don't know if that's going to be a square root. So let's go ahead and try that at 1,444 and take the square root of it. Oh, what do you know? It is a square root. Square root of that number is going to be 38, and it's going to be a whole number. Excuse me, whole number. Ooh. So that means that we are going to have 2 real, and it is going to be rational, meaning that it's not going to be a repeating number or anything like that. And one of those long numbers that don't repeat and then don't end. Anyway, let's go ahead and cover this one now. So in this case here, we are missing a b value. So that would be 0. So 0 square minus 4 times a, which is 3. And our c value is 24. And let's go ahead and multiply this out. So this is 12 times 24, which I don't really know what that would be, 12 times 24. Let me just, all right, that'd be 0 minus 288. Now, in fact, we don't really need to know the actual number, because once we know that this is going to be a negative, right, because 0 minus this is going to be a negative, once we know it's a negative, we know what kind of roots we are looking for. We know that in this case, there will be imaginary roots. If it's any number that's negative, we don't need to worry about finding a perfect square number or anything like that. If that number underneath the radical becomes negative, we immediately know there will be, well, no real solution or 2 imaginary roots. And that's how you can tell the number and types of roots, just by looking at those 3 numbers. All right, so this next one's going to be a lot of information, but this is just a quick rundown of some of the things that we've learned. And I try to say these during the lessons, but I know when the lessons are going on, there's a lot of information to take in, and you may miss some of these things. So graphing can be used sometimes. All right, there are some downsides of graphing. Some of the downsides I say when not to use graphing is when you have an a value. Because then if you have an a value, that means you're going to have to use a table. And when you use a table, that means you're going to have to evaluate that same equation over and over again, which can be time consuming. So if you notice that your roots are integers, then graphing is a good one to use. Or again, if your a value, the first term, first coefficient, is 1 or -1, that's the time I recommend to use graphing. Graphing can also be used on a calculator or Desmos, and I recommend using it to check your solutions when you do have them, and you're not sure if that's the right, if that's not the right number. And then the next one is going to be factoring. So when do you use factoring? Well, if you can, sometimes you can just look at it and say, well, okay, that looks like I can factor it. But if you know that you're, okay, so this is after finding the discriminant. So once you find the discriminant and you notice that your roots are rational, then that's probably the best time to use factoring, when you have 2 rational roots. All right, and then the next one is the square roots. So when can you use square roots? Well, okay, so this one we kind of missed early on, because remember when we were working on the one quadratic that we had, where we were using all methods, we didn't use it. So the best time to use it is when you have no b term. Your middle number is missing in the standard form. So ax squared plus bx plus c. If you have no middle term, no b term, or just the x term, that's the best way to use it. And let me just go ahead and show you really quickly what that looked like. And that is something that looks like this. where there is no x term. Right? If this number wasn't there, that would be a great opportunity to use the square root method. And then completing the square. So completing the square always works. But it works best when you have no x square coefficient. So no a value. And your b is an even number. So what do I mean by b being an even number? Well, this number here. So if this was, well, in this case, it is 6. So 6 can be halved and then squared. But if you have an odd number, it's going to be much harder to take it, half it, square it. Because if I have something like 5, right, I'm going to have to go 2.5. And then 2.5 squared is going to be, you know, a really weird number. Even if you have a calculator, it's not going to make it any easier to work with. So if you're even, your b value is even and you have no x squared, that's the best time to use completing the square. And when is it best to use quadratic formula? Well, it may not be best because it takes a long time to work, right? Because you got to take all of the things and plug them into multiple places in the formula. And you have to memorize the formula, which there are ways to memorize the formula. I suggest you look it up. There are some YouTube videos that tell you how to memorize the formula in catchy songs. But anyway, if you're not sure, you can always use it, and it works on anything. And it works on numbers, like imaginary numbers. It works on complex numbers. It works on fractions. It works on like one solution things. Like literally, it works on anything, okay? It literally works on anything. But again, the big downside is you have to memorize the formula, or you have to have access to the formula. Anyway, let's see. We only got 2 more slides to go, so we'll go ahead and wrap this up pretty soon. So here we have 4 different equations. And for now, it says to find the discriminant of each equation and give the number and types of roots. So pretty much the same thing we did earlier. So let's go ahead and b squared minus 4ac. So that's our discriminant. So b squared, in this case here, I'm going to put negative 9 squared minus 4ac. And I'm going to do this a little bit quicker. I'm not going to go step by step on these. I'm just going to go and try my best to kind of cover this in a fast manner just to show you how it works. So in this case here, we got a negative number. So here we have 2 imaginary roots. All right, and again, I'm going to do it kind of quick, just so that way you can see how fast this is, because if I went step by step, you'd be like, oh, that doesn't seem very helpful. It's really takes a long time, all right, or something like that. So here, okay, we got a b value of 0 minus 4ac. And in this case here, I don't even need to multiply it out. I already know it's going to be a positive number. But I guess actually it would help out. Let me go ahead and multiply 8 times 144, and that's going to be 1,152. And from here, let's see, is this a square number? So I'm going to move over to my calculator and see if this is a square number, 1152. Take the square root of it, which this is not a square number. So that means that we do not have rational roots, which means they are going to be 2 real irrational. Oh, can't type today. So in this case, this would probably be a good candidate for quadratic formula. Or it could also be another one that we could use for, actually, I would say square roots, because we're missing the b value, right? This would be perfect for square root. This one, since we have an imaginary root, it's probably best that we use quadratic formula for this one. All right, anyway, continuing on. So b squared, so negative 22 squared minus 4ac. So 22 times 22, what is that going to be? 484 minus 84. Oh, okay, that's going to be 400. So my discriminant is 400. And I'm pretty sure this is a square number, but just to show you, 400, take the square root, we get 20. So that means that it is a perfect square number. So that means that we will have two real roots. And they will be rational. And this is a pretty good candidate for factoring. I mean, I'm looking at this, and 3 times 7, you know, that's like one number off from 22. So I'm thinking factoring is going to work pretty well for that one. And this is something that usually takes a little bit of time looking at them and trying to find out which one is going to be the best method. All right, so 6 squared is 36, and negative, so I have two negatives, so that's going to be 60, and that would mean that this is 96. And I don't think that 96 is a rational number. I mean, I'm sorry, it's not a square number, so if we take the square root of it, we will get an irrational number. All right, so what do we do with this information? So like I was saying, once you kind of know where these numbers, once you know the discriminant, right? Once you have enough information, you can kind of tell which is going to be the best method for solving each type of quadratic equation. So let's go ahead and go through here, and I have choosing the best method. So we have factoring, which is the 3x squared minus 20 plus. It's this one right here. Sorry, I have trouble talking sometimes, and I have to kind of slow down a bit. But let's go ahead and cover this pretty quickly. So I said this is a good candidate for factoring, so I'm going to factor in. So I need two numbers that multiply to 7. So two numbers that I can multiply to 7 would be, let's see, looks like we're going to have to, let's see. We have a number in the front, so that's going to be, we're going to change this up a little bit before we start working with it. So got to get rid of this first number. Oopsie. And we use the AC method. There we go. Now I'm going to go ahead and factor this out. So I got two numbers that multiply to 21, which is 3 and 7. And it says to use each method once. So if I use one, then I'm not going to use it again. Minus and minus. But then I also need to get that number back. Actually, hold on a minute. This would be 21 and 1. 21 and 1. but then the 3 is still here, so I'm going to have to divide them by 3. So that's going to be x equals 21 divided by 3, which is 7. And the other one is 1 divided by 3, so that would be 1/3. All right, now again, you could probably do this a better way. You could probably do this a much better way than the way I just did it. Let's see, it looks like we have a typo here. All right, there we go. Now, this one here is the one I said we should use the square root method on, which is I'm going to minus 144 from both sides, so I get negative 2x squared equals negative 144. Now, I probably should have also minused the negative 2x or added 2x squared to both sides. But this is okay. It works too, in a way. So this would be, let's see, divide both sides. So we get x squared equals 72. And then I'm going to take the square root of both sides. And it doesn't really matter whether it's a square number or not, because we can't change the type of solution. And let's see, 72 is 36 times 2, which 36 is a square number, so that would be 6 times root 2. And that is probably the best method for that one. And for this one, let's go ahead and complete the square. So take our 6. So take it, half it, square it. So that means we're going to need 9 in there. So I'm going to put 9 in there. And this is mostly review here. So I am going a little bit quicker. If you need any of those other refreshers, then you may have to, take those refreshers. But this lesson is kind of assuming that you already know a little bit of this already. Okay, there we go. So I added 9 to both sides so that I can make this into a perfect square trinomial. X plus, and then I need, 3 times 3 is 9, and 3 plus 3 is 6. So there we go. And here I got 25. Oh, wait, hold on, 24. Because it's plus 9. Take the root of both sides, so square root here, square root there. And I get x plus 3 equals plus and minus. And let's see, 24, I'm going to have to do the same thing with 24, is 4 times 6. So take the square root of 4, we get 2, and 6 stays in there. And it looks like we're going to have an irrational number. So this is why it's a good idea to know what the discriminant is before writing out the before having to carry out the solution. So let's go ahead and write our answer down. So I'm going to minus 3x from both sides. So negative 3 plus and minus 2 root x. So all I did was just move it over to the other side. There we go. And again, it's a rational, and I'm sorry, an irrational expression. So we don't need to go any more than this here. So we are done with this. All right, quadratic formula. Start putting this together. 9 plus minus and 81. I'm going to kind of go a little bit faster on this. 4 times 21. What is 4 times 21? 4 times 21 is 84. In fact, this would actually kind of be helpful if I just look over here. 81 minus 84, and that's going to be this one right here. So I already know it's going to be an imaginary number. In fact, I could have just looked at this. Since I already had it, I would already know that this was just going to be negative 3. So 9 plus and minus root negative 3 over 2. All right, I wouldn't even have need to have done all that math just now. I could have just looked at the discriminant that I had earlier. All right, so now I got to take the negative out. So take that negative out. So that way it's not negative, but is now represented as imaginary number. And this seems to be as far as we can go, actually. I can't reduce it because 9 cannot be divided by 2, and there's nothing to divide out from the I. So we're pretty much done with this. And again, this is just a quick rundown on how the best method can be chosen on a particular quadratic. Now, some of these, again, are a little bit arguable. Like with this one, I might have just gone with a quadratic equation instead. But it says to use each method once. So I could have also factored this one, but it would not have worked at all because of the imaginary number. Anyway, that's just about it for now. But, and that's pretty much it for today. As always, I'll be around a bit if you have any questions. If not, then I will see you guys later. Goodbye now.